it's just a lot.
Yeah.
It is too long.
I feel like at that point they should split the bio and chem students up, and it's just like
You don't
the
have
bio
to do the
students
chemistry
should
ones
present
if
in
you're
front
not
of
a
that.
major. That'd be nice.
Yeah.
Because I don't understand any of the chem ones. I sit there and I'm like, you could be speaking a different language to me right now.
That would make sense to me, but
I just have to find subs for work for like, for 4 days basically.
you do what?
I have to find a sub for work.
Oh, yeah, that's a fact.
Word.
Like bio ones,
Yeah,
like,
'cause I
those
tutor.
biscuits, so.
So I have to get somebody to cover my shifts.
Weird.
It's gonna be painful.
All right,
Put way too much in it.
some bookkeeping things. If you go onto the Moodle site, you will see that I have uploaded a new version of the course schedule. So look at that. At the very bottom of the course schedule, I have added literature summary assignments for those of you who haven't done a covering of the paper yet. So So, if you look at the schedule down here, Kennedy and Logan did the Joseph and Pincho. Claire and Jackson will do Parker and Simmons, which is coming up on the 19th of February, I think it is. Caleb and Haley, Brody 1993, Haley and Luke. Wait a minute,
Why am I going twice?
why are you going twice?
I'm not even.
I don't know what that is about.
Jalen.
Who's not on here then?
Jalen.
Jalen.
Jaylin, sorry. Jaylin is who's supposed to be there. Haley and Luke, and then Alexis at the end. Alexis, you're gonna be by yourself because we have an odd number of people, so you've just got Prole and Hodel all to yourself.
Oh.
And, sorry, so I'll fix that. It's not even spelled the same. I don't know what I was thinking.
Is that at least a short paper?
No, but it's interesting. It's about sex and frogs.
Ah.
Nice.
Sex and poison dart frogs, so they're colorful, and it's about sex. So there you have it. So when you also go on there, you can see that I have added under February 19th. You'll see the Parker and Simmons papers there. When you go down to March 2nd, there are 2 papers that week. One is the Brody paper from 1993 about coral snake mimicry. The second one is by Brody and Jansen that is also about coral snake mimicry. You need to write a literature summary over the Brody paper, but you need to come prepared to class to discuss both. So they're both in that folder.
Wait a second. We don't write a literature summary about the Parker or whatever?
Yes, Parker and Simmons, you write one about that. On March 2nd, there are 2 papers, Brody 1993, Brody and Jensen 1995. You have to write a literature summary over the Brody paper, but not the Brody and Jensen, but come to class prepared to discuss each of them. Write a literature summary over Brody, but read both and come to class prepared to discuss both. It's there in English. And then all the rest of them, there's just one paper. But anyway, they're uploaded, so if you want to get an early start on things, May 6th, Prole and Hodel, they're all there. So you can access them at any point. Questions about that?
So I'm with Luke.
You are with Luke.
Okay.
Caleb is with Jalen.
Okay.
Yes, and I'll fix that on the schedule. All right, any other questions about anything? Tomorrow in lab, we can sleep in a little bit and get started at 8 because we just have finishing up last week and then new stuff for this week. And the new stuff for this week isn't as extensive as the stuff for last week was. So I think we can start giving ourselves 15 minutes more sleep and still get everything done. After that, we'll have all the data, and I'll post a spreadsheet on Moodle so that you can put your data into, your individual data into a spreadsheet, and then I'll combine everybody's data. And then next weekend lab, what we will do is we will talk about data analysis and talk about what it all means in a sense.
Do we have to write a lab report over this lab?
Oh, yeah. Looks like great. Yay. Yes, ma'am.
I won't be here for the rest of the week,
Starting.
tomorrow.
Okay. Then speak to your friends about what we do. And your group of 3 is gonna have a little more trouble tomorrow than they would. Because you won't be there. So I might have to pitch in and do some time, which is fine, I'll cover you. All right. Today, we're starting material that will be on the next exam. This material deals with economic decisions. One of the things that I like about this textbook is that it takes a quantitative approach to things. And one of the ways it takes a quantitative approach is in this chapter actually sets kind of the stage for a lot of things that they talk about in the rest of the book, which is basically using concepts that are normally found in economic theory to understand animal behavior. So I want you to be able to apply economic thinking to animal behavior. We're going to talk a lot today about what are known as diminishing return curves and what those mean for behavioral decision making. We're going to specifically talk about how they affect foraging decisions and mating decisions. We're going to explain what the ideal free distribution is. The ideal free distribution is this interesting idea that for you guys is most applicable in shopping lines, at the checkout counter, at the supermarket. We're going to talk about risk as a factor in decision making and how a risk can affect the decision that an organism makes. And then talk about cognition and learning. So I was looking on the schedule, and it's like there are a lot of days devoted to this chapter. We might move through it a little faster or a little slower, but I think we're probably going to move through it faster. But there's a lot packed into this one chapter, so we need to take our time getting through it. So that's kind of what I want you to be able to do by the time we're done with this chapter. So this is my couch in my house. It's made by a company called Stickley Furniture Company. It's a company that's been around since the late 1800s, early 1900s in upstate New York. This is made out of red oak. It is handmade by a group of woodworkers who work at this fabrication facility. The fabric is handpicked from a period set of upholsteries that you can buy and pay extra money for. It's all done with traditional joinery, mortise and tenon joinery. It's heavy as hell. It will outlast me. I will give it to my non-existent children. No, I'll give it to my nephew. He will probably give it to his children. His children will give it to their children. It's a piece of furniture that will span generations. It costs about $4,000. Now, why would you spend $4,000 on a couch? Well, for a number of reasons. One, it's just beautiful. This picture doesn't really do it justice. It's beautifully finished. It's beautifully built. It will outlive me by a lot. It fits the period of my house, so it's after a design that is about the same age as my house. There's a similar little side table right here made by the same company. So one of the reasons that I paid that much money for it is because it's durable. The other reasons that I paid this much money for it is that it's built by American people who all have health care and workers' compensation insurance and life insurance, and if something happens to them on the job, there are insurance policies for them to receive their salary when they are recovering. et cetera, et cetera, et cetera. So it has a lot of other benefits built into the cost of it. So I'm not just paying for the cost of materials, I'm also paying for, environmental protections done by the company to prevent woodworking that can be environmentally damaging from being quite so damaging. They treat their workers well, they pay their workers well, they have health insurance, et cetera, et cetera. All that is tied up into the cost of this little settlement that sits in my living room. I could have gone.
Is your couch comfortable?
It is comfortable. It's not comfortable to lay on, but it's comfortable to sit on because it's small. I have a small house, so in my living room wouldn't really fit like a full-size sofa. It would just kind of, a full-size sofa would take over the living room. So I have a settle, and then I have, made by the same company, I have an old-timey, it's called a Morris chair with an ottoman that I bought when I got tenure. And so all the furniture in my living room is, for the most part, arts and crafts furniture made by this one company. I could have gone to Nebraska Furniture Mart and bought a similarly styled Mission 2-seat sofa thing for about $400. But I would find myself buying this same thing again like 5 or 10 years from now, because it's not made out of real wood, it's made out of particle board that is just covered with a veneer. It's not terribly heavy, it's not terribly durable, cheap ass microfiber seat covers, et cetera, and I'm going to have to replace that thing periodically over the course of my life, whereas I don't plan on ever replacing this thing. My girlfriend was eating chocolate once while I was out of town. She spilled chocolate all over one of the pillows. She was like, oh my gosh, Paul's gonna kill me. I spilled chocolate all over this fabric. And we just got a damp washcloth that was warm and washed it out, rubbed on it, and after a couple of rubbings, it just came right out. So amazingly durable, but also on the expensive side. So somebody who doesn't make very much money, and my salary is $62,000 a year, for those of you who are curious. Somebody who makes $62,000 a year doesn't just go out and buy spend $4,000 on a single piece of furniture, unless you've gone through the economic cost-benefit analysis of what am I buying, why am I buying it, how long am I going to keep it, et cetera, et cetera. For me, it's a good investment because I'm never going to have to buy this piece of furniture again. So part of it is I just don't ever have to think about it ever again. I've bought the last couch I'm ever going to buy. And then the other part of it is, well, what are the other benefits of buying it? I've already told you what they are. They treat their workers well, they have workers' comp, they have unemployment insurance, they have health care, et cetera, et cetera. That's all a good deal for me. This is put together somewhere in Asia, where the people who run the factory don't care anything about the environment around the fabrication plant. They don't pay health care for the people that work there. There are no legal protections for worker safety, et cetera, et cetera. And as a result, you can buy this thing for like $400 as opposed to $4,000. And I choose not to go down that path as often as I can make that choice not to go down that path. So economic decisions are all about costs and benefits. What are the costs to you, and what are the benefits that you accrue from that? And human beings can make those decisions in the furniture that we buy, the cars that we buy, the shoes that we buy, the clothes that we buy, et cetera, et cetera. And we do, constantly. When I grew up as a kid, we were poor, we were dirt poor. And we made all sorts of buying decisions that are different than the kind of buying decisions that I make now, simply because we were kind of on the margin of going under. And my parents just made a set of economic decisions that are different because of the financial situation that they were in. I'm never going to buy that couch right there because I just won't do it. Economically, it doesn't make any sense to me to do that. So when we think about economic decision making, it's all about balancing costs and benefits of the various choices that are available to an individual. I could have said, I'm not going to buy a couch at all, I'm just gonna buy 5 beanbag chairs. Much cheaper, they're pretty durable, sort of comfortable. Do you guys find beanbag chairs comfortable? I always find they make my back hurt. So I had a lot of choices that I could have made. I made one particular choice because I like the style, but if I'm gonna go for that style, I'm gonna buy from an American company that does things the way that I like to do things. It relies on the quality of available information. So when you make an economic decision, it's important to do research. Elizabeth, my partner, and I just bought a new car because her Jetta was a piece of junk. So my plan this summer is to build a teardrop camper. It's a little camper that you can pull behind a small car, weighs less than probably around 1,000 pounds total when it's all said and done. I can make it out of wood. I have the woodworking skills in order to fabricate it myself. And so we were thinking a Toyota Prius, which is what I normally drive, doesn't have any towing capacity at all. As a matter of fact, it says in the owner's manual, do not tow anything with this. You're not even supposed to put like a hitch on it to like put your bike rack on there, but of course I've done that. So we were looking at wanting to have a teardrop camper because last time we went camping, my 13-year-old tent sprung leaks and we were wet for a good chunk of the time. And so we're like, well, we need to either get a new camper or we need to do something different, need to get a new tent or we need to do something different. So we had been looking at teardrop campers. So one of the decisions that we had to make was, are we going to buy a car that has some towing capacity, something like Subaru Outback, that also allows us to go a little bit off-road because she thinks that I take the Toyota Prius places that I should not be taking the Toyota Prius. And she's probably right in many cases. And so we were looking at the Subaru Outback because it's got 1,700 pounds of towing capacity. And the problem is she lives with me here in Liberty, but she works at KU. She's a postdoc at KU, so she drives a lot. And so we thought about it for a couple of months because we don't make any decisions until we've thought about it for 2 to 6 months or maybe longer at times. And we finally decided that the thing that we need to do now is get a new Prius that doesn't have 256,000 miles on it. And when we finally get a trailer built and have a need for a towing vehicle, we'll trade in my Prius with 256,000 miles on it and get an Outback at that point. Once again, we went through this process of economic decision making, but we had to think about all of the information that we had. What's the mileage of the Subaru? What's its upkeep costs? Her Jetta was a perfectly comfortable car to drive. It was a diesel, it got pretty good gas mileage, but because Volkswagen sucks in some ways, it needed like $9,000 worth of work done on it because there is this filter that is basically, it's a particulate filter that filters particulates out of the tailpipe emissions, and it's located on the back end of the engine such that to replace this filter, it's a filter, it's going to eventually need replacing. You have to take the entire engine out of the car to replace it.
It's foreign car. It's foreign, that's why.
Well, whatever. What it is it's $9,000 on a car that's been nothing but a problem. So we spent time researching, figuring out what the available options are, and we decided to go with a much more economical choice for what the car is going to mainly be used for, which is a commuter to drive back and forth to KU every day. So what is the quality of the information? The nice thing about cars, you can get a lot of really high quality information about cars. Harder to get information about where little worms are located out in a field or something like that. Requires certain cognitive capacities of the organism making the decision. Luckily for us, we have cognitive capacities. We can make decisions in an informed way. We can also make decisions in totally uninformed ways if we want to. And the other thing that humans do sometimes is we make a bad decision and we know when we're making it that it's a bad decision. Because we want something and we don't really care about the economic costs and benefits of that decision. If you do that as an organism out in nature, you end up dying sometimes. So imagine, this is an example that actually came from one of my professors when I was in graduate school. Imagine that you were a badger out in the field, and there are a bunch of small rodents. In this case, these are star-nosed moles, because I could find a star-nosed mole graphic on the internet. And you don't know where these moles are located in a field, but you're going to enter the field and you're searching for prey. And what happens is, as you're wandering around, you encounter a mole. You're like, oh, a mole, I'm going to kill it, I'm going to eat it. But where there's one mole, there may be other moles. So what you do is you change your search pattern until you've found what you think are all the moles in this patch. And then after you stop finding moles for a little while, you go back to a more kind of random linear search model. You encounter another mole, you circle around in that area until you think you've exhausted the mole supply there, and then you start searching again until you encounter another patch of moles, and you exploit that patch until you think you've fully exploited that patch. This is a set of models, or a way of thinking about the world that falls under the general category of patch models. And out in nature, many times the food that you are looking for isn't distributed uniformly in the environment. It's distributed in a non-uniform fashion. It's distributed in little patches. And these patches may have different qualities, i.e. different amounts of food in the patch. You may have some patches that are really rich in food, and you may have other patches that are not so rich in food. And so the question one question that an organism has to make is, after I know that I've entered a patch because I've encountered some food, how long am I going to stay in that patch before I decide to leave that patch and go in search of another patch? That's a fundamental question that some organisms have to deal with. Well, we can use a thing called the marginal value theorem to address this question. So let's say that you have two patches, patch type 1 and patch type 2. This is the amount of energy that you take in while you're in that patch, and this is the amount of time that you spend in the patch, sometimes referred to as patch residence time. So if you encounter patch type 1, you get more food per unit time that you stay in there because it just has more food to offer. So this is a richer patch, this is a less rich patch. But what ultimately will determine how long you should stay there, because there comes a point where staying in there for a longer period of time doesn't really gain you much in energy. That's why these are called, I used the term earlier, no, it's not in my mind. Oh, diminishing returns curves. Can you think of something that a diminishing return curve applies to in your life?
Studying.
Studying. If you don't study at all, what's your grade going to be?
Poor.
Very poor. If you study a little bit, your grade goes up relatively quickly and will continue going up. But the more you study, the less more studying gains you. And there comes a point at which spending 2 more hours of studying does practically nothing to change your grade. And at that point, what should you probably do? Yeah, go to bed, stop studying. And so life is full of diminishing returns curves. Study a little bit, you gain a lot. Study a little more, you gain quite a lot more. Study more than that, you gain less. Study more than that even, you're gaining even less, until finally there comes a point where you should just stop studying and go do something else with your time. My advice, go to bed, get a good night's sleep before you wake up the next morning and have to go and take the test. Generally speaking, you will do much better on a test if you get a good night's sleep than if you stay up all night studying. diminishing return curves are ubiquitous in life. So the question is, how do you, the organism, decide when to leave a patch to go in search of another patch? What kinds of things do you might think would affect that? Anybody but Logan who's looking at the answer. Remember that these patches are distributed in space. So the question is, how long do I stay in this patch? Because I have no idea. We can see the number of moles that are in this patch. I, the forager, don't have any idea what is in this patch. I'm just looking and hoping to find something. How do you decide when to stay in this patch longer versus when to leave this patch and go searching for another patch?
Energy output. It's like how much energy it's costing you to stay there and keep searching versus how much you're actually getting back.
So that's what this relationship is all about. If I stay here and search more, how much energy am I going to get in the event that I find something? But this is actually the thing that will determine whether or not you should stay in here for a really long time or a really short time is going to be determined by another thing, because ultimately what you're trying to do is you're trying to maximize the rate of energy intake. And so the easiest way, the best situation is this is my scrolling from last time, 2 times ago. When it comes down to it, the rate of whatever it is, the rate relating energy intake to time spent in patch, the rate of energy gain is the tangent of the line where it intersects the curve. So if you want to maximize your rate, how long should you stay in the patch? Well, your rate starts decreasing immediately, but you experience the fastest rate where? As soon as you enter the patch. As soon as you enter the patch, you are achieving the maximum rate of energy intake, but what that would mean is that you're going to basically eat one paradigm and then move on to the next patch. That's probably not the best strategy, especially if what is the relation between the patches? Patches can be close together, patches can be far apart. If patches are close together, what's your travel time from patch to patch? Short. If patches are far apart, what is your travel time? What do you need that whole time that you're traveling? You need energy. So if patches are close together, you can. Why would you stay longer?
You can
Save energy.
You can visit
while
more
still-
patches.
No,
If
if the
the-
patches are
you can
close
visit more
together,
patches.
you leave more.
Yeah.
If patches are far away, you stay longer.
Yeah, if a patch is close together, so if this is travel time, if patches are really close together, if this is travel time from short travel time to long travel time, it's easy to leave a patch because there's another patch nearby that you can go and get. And when you encounter that other patch, the rate of energy return that you get is going to be relatively fast. If patches are further apart, you would want to stay in the patch that you're currently in, experience less efficient foraging, but you would have way more energy. So even though the rate here is relatively high, the amount of energy that you have is relatively low. Here the rate is lower, but the total amount of energy that you have is approximately twice as much. So travel time between patches ultimately determines how long you want to stay in a patch, because even though you may get a lower rate of return as you stay in the patch longer, you're harvesting a total amount of energy that is greater in quantity. And so the marginal value theorem basically says exactly this. It relates travel time to patch residence time, such that you can draw a line from travel time to where it meets the curve. And so this would be the patch residence time for this rich patch that is this travel time away from another patch. What would happen for the poor quality patch? You're gonna stay in there longer or shorter than in the rich quality patch?
Sure.
Why shorter?
There's not a lot for you.
But this is the average patch of the habitat. So every other patch that you encounter, you should expect to have that same level of energy in it.
Oh, okay.
Well, what's the easy way to tell? If they're still both the same travel time away, what do you do? Draw a line from the travel time to the curve. And I suck at this because I do not have a ruler, which you will have on the test. Or you should have, oh, that's a terrible line. I've already done it. This is what the line looks like there, and as you can see, you should stay in that patch a little longer because it's poor quality, and you still have to have enough energy to make it to the next patch. And so travel time for a poor quality patch versus a good quality patch is going to be different when you leave travel time constant. You could continue staying a really long time in this poor patch, but even if you stay a really long time, really way longer than you should, you're never going to reach the same amount of energy that you would if your patch type was better quality. So this is the marginal value theorem. It was proposed by a guy named Eric Chernoff in 1976, and it does a pretty decent job of describing patch residence times, or what is sometimes referred to as giving up times, GUT. What is the time that you give up on the patch that you're currently in and move off to another patch, to search for another patch? So there are a series of things that an organism has to keep in mind. The organism has to keep in mind how long it's been in the patch. The organism has to have some idea of what the distances are from one patch to another patch in their particular environment. And they need to have some idea of what their rate of energy gain is. And if they have those three pieces of information, they should be able to make decisions about when to leave in search of another patch versus staying in the patch that they're currently in. Yeah?
What about like considerations of predation?
We'll get to that at the end of the chapter where we talk about risk. Certainly that would matter. So patches can also differ in terms of risk associated with them. One of the risks is a risk of starvation, but other risks are things like risk of predation. And if traveling from patch to patch incurs more starvation, that may make your giving up time extend beyond what you would expect, simply on the basis of energetic concerns. So as soon as you add predation risk in there, you change things because you've added this other variable. And what you find is, in the literature, as you learn from reading Lima and Dill, is that if you have a choice between a rich patch and a poor patch in an environment, but the rich patch is associated with more predation, you might still go and forage at the poor patch, even though you're going to get less energy if the probability of being killed is high. So as soon as you add that extra level in there, you have to think about how you balance energetic demands versus staying alive from predation demands. This is another common theme in animal behavior, this idea of balancing conflicting demands. You're a clownfish and you're thinking to yourself, oh, there's some food over there, but there's also a barracuda over there. I'm really hungry. How hungry do I have to be to go over and get that food when I know that I might be killed and eaten by a barracuda? Logan, you had a question.
Yeah, before you answered Alexa's question, you said that there were like three things you needed to know to make an informed decision. What were they?
You need to know how far apart the patches are typically in your environment. You have to know, what the rate of energy gain is that you can expect to get out of any given patch. And you have to have some way of assessing how much time you've been in that patch. So one of the questions that some people have sometimes is, do animals, non-human animals, have a good sense of time? And the evidence would indicate that they generally do, because they have to have some sense of time in order to make these kinds of decisions. And they generally make decisions that pretty much conform to what we would expect them to do in terms of time spent in a patch. Even insects can do this with their little pinhead-sized brains. We can examine the same model where we vary patch distance, inter-patch interval. So this would be the situation if the patches are far away from one another. But if the patches are closer together, we have near patches. Because travel time is less, meaning also that travel is less energy and expensive, you can afford to take in less total energy, and as a result, get a faster rate of energy gain by shortening your patch residence time. And so here we have the patch residence times or giving up times for a high quality patch that is near, a low quality patch that is near, a high quality patch that is far, and a low quality patch that is far. Once again, if you know what your distance is between patches and you know what quality on average is in your environment, you can, in theory, easily make these decisions. Is there anything in your life other than studying that this applies to? Something that I do at least 3 times a week. Hmm? What?
Showering. I don't know, that just popped in my head.
You shower 3 times
I
a week?
shower more than 3 times a week.
Really, I don't.
Drink a beer.
Actually, no, the interpatch interval is really short for beers, unless you have a really terrible waitron. Like my waitron last night, I ordered a New Belgium 1554, which is a nice dark beer, and she brought me a New Belgium Voodoo Ranger, which is an IPA, which makes me want to barf. And when she set it down in front of me, well, she asked me actually twice. I asked her for a 1554, and then she came back and she's like, "What do you want?" I'm like, "A New Belgium 1554. It's right here on the menu." And then she went away, and then she brought me a Voodoo Ranger. I'm like, "I cannot drink this. I hate IPAs. I will drink this and it will make me puke." She's like, "What did you want again?" I'm like, "A New Belgium 1554. So it took me forever to get my beer at Old Chicago last night. But I finally did get it, and it was very nice. I enjoyed it. Do you ever misplace something and you're looking for it frantically?
Yes.
Like your car keys,
All
your wallet, whatever? After a certain point, what do you want to do if you haven't found it? You want to just give up. So this happens at our house occasionally. We've set our wallet down somewhere, we don't remember where we put it, we're both running around looking for it, and there comes a point where we're just like, screw this. One of us has a wallet, one of us can drive, one of us can pay. We don't actually need 2 wallets to go and do whatever it is that we're doing. We'll find the other wallet later, because we've reached the giving up time, because we maybe have an appointment, we're going to meet people for dinner or whatever, and time is passing us by. There are things that you do where you finally just do give up on whatever that thing is, because the time that you've spent in that activity isn't gaining you anything else that you hope to gain from that activity. Looking for keys is one of them for me. Looking for wallets is one of them for me. terrible relationship? What are you getting out of the relationship? Satisfaction, love, companionship, et cetera. You can only gain so much of that from a particular person, and once you stop getting any more of that, you start to ask yourself, why exactly am I in this relationship? Well, the reason that you may stay in that relationship for a longer period of time is because you have to consider, well, if a relationship is actually important to me, how long am I going to have to wait for the next relationship?
That's fine. I've never thought about it like that.
You've never thought of it that way?
No.
Trust me, you're doing that calculus whether you think you're doing that calculus or not.
Say it one more time.
Jackson doesn't know this because he doesn't have a relationship. Sorry, that was me. I take that back. I have no idea what your social status is.
I just didn't understand what you were saying.
Oh, how long do you stay in a relationship before you get out if it's not really giving you what you want out of it? Well, part of that's going to maybe depend on how important a relationship is to you and what's your projected time before you're in another relationship. What's your travel time? What's your travel time, in a sense, from one person to another versus where are you at on this diminishing returns curve in your current relationship?
I just feel like it ain't this deep. Like, what if it's just like an animal and a patch of food and it's eating until it can't find some food and then it just leaves and it has no concept of any of this and we've just like made this up?
So what you would expect is when you go out, so I had a professor who studied badgers in England, and what he did was he put little clusters of peanuts in a field. And it's a very memorable experiment when he told us about it. And what he did was he hung like one of those glow sticks around the neck of a badger, they're nocturnal, and he put them on a field that was like a sloping hill, and he sat on the other hill, another hill facing that hill, and watched the badger glow stick through his binoculars, and watched him do.
How do you get close enough to a badger? How do you get close enough to a badger to do this?
Trap it,
Oh.
and he watched him do exactly this.
And the badger
Damn,
is cool with how it goes.
crazy as hell.
He watched the badger glow stick, and the badger would be kind of wandering around aimlessly, but you could tell from the movement of the badger as soon as the badger came in contact with a peanut, because he would stop and he ate that peanut, and then he started going around in really tight circles looking for other peanuts. And he would do that until he thought that he had exhausted that patch, and then he went back to kind of a more widely roaming random sort of pattern, encountered another patch of peanuts, started eating that patch of peanuts until he figured that he had spent enough time. And what happened when you did this is you found that they did exactly these kinds of things. And you might think about this, if you were analyzing this mathematically, the math is actually kind of complicated to get to this. But organisms, animals, are capable of actually doing the math, so to speak.
Well, that badger didn't know when he was gonna reach the next patch of peanuts. He just was roaming around until he reached some peanuts.
So he roams around until he reaches the peanuts, then he's like, okay, I found food here. A decision goes off in his brain because he knows how food is normally distributed. Where I find food, generally I find more food, so he starts that constrained search. That's what it's actually called, this constrained search, until stops finding food. Then he moves around the field. As soon as he hits that second patch, now he has an estimate of what the distance from one patch to another is. Because he knows where the last patch was, he knows where this patch is. He has an estimate of what the quality of patches are in this environment from the last patch. Now he can modify his knowledge of patch quality depending on what this patch is like. Now he has two estimates of what patch quality is on average in this environment, and he has one estimate of what inter-patch interval is. At that point, he's got really everything he needs to know to start making economically based decisions on how long he should stay in the third patch that he finds, because at the time that he enters the third patch, he will now have two estimates of inter-patch distance, as well as two estimates of quality of patch. And at that point, he really has everything he needs to know, as long as he can keep track of time. Yeah?
So when you fish and you have like a bait on a hook, are you essentially like going in their patch? You know what
Are
I'm
you
saying?
thinking of it from a fish's perspective or
Like
from a
fish that's
fisherman's
searching- like
perspective?
A fish perspective. Your little fish is swimming around, going throughout the water.
Yeah.
And it just goes on there. It's in the patch.
Yeah, but it's a patch of one unless you have multiple
Yeah, but
fishing rods.
I'm just trying to make it make sense.
It's much easier for me to think of the fisherman. Fisherman drops his hook and waits. And waits and waits and waits and waits. At what point does that fisherman decide that this is a really poor quality patch, pack up his gear and go to another patch? It makes more sense from the fisherman's perspective. Now, the thing about catching a fish is you're going to be better off from catching fish's perspective if you are actually fishing in a place where there aren't a bunch of other food resources available. And so it's better for the fisherman in terms of catching fish if the patch is a patch of one worm on the end of the hook. Because then the fish has a choice, eat the worm or don't eat the worm. Because it's a patch of one. And once again, if you're a fish and you primarily feed on worms, you can probably visually assess the quality of a particular patch. Which makes you wonder how you ever get any fish at all. Because I would hope that a fish would learn relatively quickly what a worm looks like on a hook versus what a worm looks like not on a hook. And they also have the ability to look around the water column and see, is this a patch of one or is this a patch of a lot of possible worms? I don't know how fishing works. I've been effective at fishing before and ineffective at fishing before, and I don't know that there's a pattern, for me at least. Fish do respond to prey quality though. So you can dribble prey into two ends of a tank, and if one, and so this is a set of experiments that have been done. Actually, we're not there yet, but the ideal free distribution. The ideal free distribution basically says that if everybody in your population has complete information, you will distribute yourselves around your environment in such a way that everybody gets the same amount of food. So you can set up a tank where there's a pipe going over the tank on this side, there's a pipe going over the tank on this side. You can put a line down the middle of the tank with a marker, and this tank is dribbling little brine shrimp out. Brine shrimp, you guys know what brine shrimp are? They used to call them water monkeys back when I was a kid. Why? Sea monkeys, yes. So you can dribble brine shrimp out at a certain rate on this side, and you can dribble brine shrimp out on this side at half the rate. And if you put 12 individual fish in this tank, the fish will distribute themselves such that 8 of the fish are on this side and 4 of the fish are on this side. Because as these 8 fish feed off of this thing, each fish is getting the same amount of food per unit time as the 4 fish on this side. And it isn't that 4 fish go over here and stay over here and 8 fish go over here, but if you go and look at the tank periodically, you will always see approximately 8 fish on one side and approximately 4 fish on the other side, because they can assess what the quality of this patch is, they can assess what the quality of this patch is, and they know how much food they're getting. And as soon as you take one of these fish and it goes to this side, immediately what happens is it starts suffering lower rate of food capture than it did when it was over here. If you're over here and somebody comes over here and starts eating, you see that your rate goes down, and so you go over here, restoring this balance. So on average over time, you'll see that on average you get about 8 individuals on one side and 4 individuals on the other side, because they can assess their own rate of energy intake and they can assess what the quality of these patches are.
Is it the quality food or the concentration of food?
Well, in this case, the quality of the patch is how much food is
Okay.
there. What's the rate of delivery of food? And this has been done a gajillion times before with fish. Fish can see the food, and they know what their own rate of intake is, and so they make decisions as to whether I'm gonna stay here, or whether I'm gonna go over there where some food is. Then goes over there and discovers that there's less food rate, lower rate of food intake over there, and then somebody leaves and then their food intake goes up, or they themselves leave and go back to where they were before. Because everybody gets the same amount of food as long as this ratio is maintained. What, Alexis?
I said, like, I don't know, it just seems like a sad life, like they just spend all day thinking about when they're gonna eat, and that's it.
So animal behavior is basically a class
Same.
about sex and feeding. You can bust so much of this class down to is an individual making a decision about eating, or is it an individual making a decision about sex? And once you get beyond that, you can think, well, in order to get a mate, do I have to go over there and risk higher levels of predation, or in order to get a meal, do I have to go over there and risk higher rates of predation? How long do I mate with this individual versus mating with this other individual in order to maximize my reproductive output, et cetera, et cetera? Yeah, it's a sad life. You have basically two things that you have to see to you. Surviving to the next day, which means getting enough energy to survive metabolically to the next day while not becoming prey for something else, and somewhere in there you have to find somebody to mate with. That is what animal behavior class is about. Sex
Right.
and feeding. Because we can think about this from the standpoint of birds foraging. This is an example from your textbook. Starlings picking up worms. The amount of load that they will pick up, whether they're going to pick up 1 worm, 2 worms, 3 worms, up to 8 worms, is determined by how long it takes them to search for and find those worms, and how far they have to travel to get to those worms. The further that they travel to get to the worms, the more worms they want to get because of the metabolic costs of going and getting the worms. And so if you look at travel times that are long, you would stay in the patch for a longer period of time, you would get more worms to bring back. If the distance between you and where the worms are is shorter, you would basically spend less time in the patch because you have a shorter trip to get back to feed your offspring. And once again, the question that Alexis has is, do organisms actually do this? Well, this is the prediction of what birds should be doing on the basis of the fact that it's a step function, because you don't get 3.5 worms, you get either 3 worms or 4 worms. So this is the question: if you manipulate how far away the birds are because you've trained them to feed at these feeders, and you can move the feeders further and further away from the birds, these are the predictions. The line is the predicted number of worms that you should pick up, and the dots are actually observations of birds that they did this to. Once again, pretty good correspondence of the model prediction versus the actual behavior of the organisms. So, do organisms actually keep these things in mind? Yes, they must be doing that because it matches what the model actually predicts.
Wait. What's the difference between A and B? Because I'm confused.
Oh, this is just, A is just showing you a generalized model. This is it for long and short travel times, travel distances. This is basically just the second graph that I showed you before as applied to load. So this is the marginal value theorem. Told you that this class is about sex and feeding. These are dung flies, basically mating. And so in this case, the time spent in copula is graphed against the number of eggs fertilized. The longer you spend as a male hooked up with a female as a dung fly, the more sperm you transmit to her, the more of her eggs get fertilized. But there does come a point where staying with her for a longer period of time doesn't gain you much in fertilization because you've already fertilized most of her eggs anyway. And so the question for the male dung fly is, how long should I stay in copula with a female in order to get the maximum number of eggs fertilized? Well, that's going to be predicated on how long it's going to be before I come into contact with another fertile female. The marginal value theorem works whether you're talking about food, whether you're talking about fertilization. It works in a wide variety of scenarios. If you're not going to come into contact with another female, you might as well stay with the female that you have and fertilize all of her eggs. If you can find another female in just a few minutes, then mate with one female for a few minutes, get a proportion of her eggs fertilized, then move on to another female that doesn't have any eggs fertilized, your rate of fertilization is going to be much faster early on with her than continuing to stay with the female that you were with before. Same relationship, this is just searching and guarding time that is determining how long you should stay with one female before going in search of another female. An ingenious little experiment that's talked about in your book is looking at a load. When bees go out and forage, they basically are foraging primarily for nectar, and so they have their gut that fills up with nectar. They can fill their gut all the way up, but they don't have to fill their gut all the way up. They can manage how much of their gut they fill with nectar before they return to the hive, and they basically do that based on what the travel time is between flowers and the number of flowers that they're visiting. That then affects what their load is. These guys basically were able to test this by putting little tiny weights on bees, increasing how heavy the bees were. The bees can assess that load that they're carrying, and then they alter their behavior depending on how far away the flowers are from them, from the nest to the flowers, and then how far apart the flowers are in terms of travel time. And the closer the flowers are, and the closer the flowers are to one another, and the closer the flowers are to their nest, they take less and less nectar, because the travel expenses of going back and forth aren't that high. The further and further apart you get, the bigger the flower load, the nectar load is that they'll be willing to carry around. So in all these cases, they're maximizing the amount of energy that they're getting access to, or the amount of matings that they're getting access to, the amount of fertilized eggs that they're getting access to, depending on how far apart new opportunities are, either in distance or time or whatever it happens to be. Questions about the marginal value theorem? Relatively simple model that has just been found to work a lot. Like, animals do this a lot. Almost anything that you spend time on, you can put a diminishing returns curve to.
Is there a roughly equal relationship between like time you spend in, what I'm trying to ask here? So with this bee example, we considered the weight that the bee's carrying,
Yep.
how close the flowers are in a single patch, and then how far you have to travel to get to a
Mhm.
new. So do all three of those carry roughly equal weight, generally speaking, if you're evaluating three variables?
Yeah, so if you were doing an experiment to assess this, so their main thing was how much is the bee willing to carry in terms of total weight. But you could certainly mess with the time aspect. And so what you would do if you were going to try and do that is because you can put flowers in pots and move them around and control distance to a hive or something like that. If you had a hive here, you might create some patches. One patch you might put close to the hive, but each individual flower might be really far apart. You might have another patch that is close to the hive, but the flowers are really densely spaced. You might have another set of patches where they're far away and also widely dispersed, and another set of patches where they're far away but really densely packed. And you could actually see how these were weighting distance among, because in this case, this isn't a patch. This flower is a patch. It has a nectary. That nectary has a certain amount of nectar in it. The longer you spend at that nectary, it's easy to get nectar out at the beginning because the nectar is close to you. And the longer you stay there, as you drink it down, you are diminishing the supply. Each flower has its own diminishing returns curve. So in this case, the inner patch time is distance from flower to flower. Added to that, if you are far away, if you have a patch that's far away from your hive, you have to carry whatever it is that you're carrying back to the hive. The more you're carrying, the heavier your load is. That also then has metabolic costs. So you could actually investigate both distance to where the food is, as well as distance among patches within here. But what you should find is that, in this case, what they found was that, the number of flowers that they visited is proportional to the load that they're carrying. And so the further they have to go between flowers, the lower the load is that they carry, because it's metabolically taxing to carry, to fly around when you're really heavy. And so, and then they can manipulate that also by taking off weights or putting on weights and changing the mass of the bee.
So the farther apart, the less nectar you're taking along?
Yeah, so, yes, did I say it opposite earlier?
Yeah.
Okay, yeah, the further apart the flowers are, the less load you carry, because it's metabolically costly to carry the load. And the point of gathering nectar isn't that you're gathering nectar for you to sustain flight with, you're gathering nectar to bring back to the hive. And so if you have to fly it a lot from flower to flower, you visit fewer flowers, you carry a smaller load because you have to carry it this greater distance. Sorry, I flipped it earlier. Prey choice can be made in the same way. Imagine you are at the Golden Corral. The Golden Corral is my favorite example for illustrating foraging decisions in animal behavior at the beginning of a particular topic where we're talking about feeding, because all of you have been to the Golden Corral. Has anybody not been to the Golden Corral? Oh, good. We all have a shared experience. When you go to the Golden Corral, what are you faced with?
A lot of food.
A lot of food and a lot of choices, right?
A lot of other people.
And a lot of old people, thank you. Although I haven't been to the
I said-
Golden Corral in quite some time.
I said other people, but yeah.
Oh, I thought you said old people.
That's
Ageist statements. So you're at the Golden Corral. You have all this food to choose from. How do you choose what to eat? Now for you guys, you're going to choose what you like, because you have preference, because you're humans, and you don't have to worry about getting enough calories each day to survive. But let's say that you are concerned primarily with that. I'm looking for the food at the Golden Corral where I can maximize my rate of energy intake. Does that then change how you behave at the Golden Corral? Okay, Logan, what would you eat at the Golden Corral if you were trying to maximize energy intake?
I'd stray away from the sugars and go more towards protein and nutritious foods.
Well, but your energy intake, you would go for what first?
I would only eat bread.
You would only eat bread. You would actually go for carbs, right? If your criterion for what is successful is getting enough energy to survive from today to the next day.
So are we assuming that we don't have an understanding of nutrition then?
So
Because you have to eat more simple carbs to get the same amount
Squirrels
of
aren't worried
total
about
energy
macromolecules.
as protein.
I don't know, is that true?
That's kind of what I've always been told, is you eat like protein the day before competition, carbs the day of, because it's short term.
I thought like
So you
during
eat
track
spaghetti,
stuff, you eat like
spaghetti the night
pasta.
before.
Yeah, you eat 2 days
But you
before
never
you
eat spaghetti the day of.
And then 2 days before you'd be eating the steaks or whatever.
Oh, you guys have been trained by different people. So, when it comes, so,
Maybe heavy carbs today.
so,
That's what
Now
you
we're
get.
having an argument about golden.
on the y-axis here, what is this? Energy. Pound for pound, if you're just measuring calories, what has more calories, carbs or protein?
Carbs.
Carbs. So if that's what you're concerned with. Now, if you ate nothing but carbs, your long-term strategy would not be great because you wouldn't be replenishing amino acids, which you need, et cetera, et cetera. But in the short term, on any given day, you have to meet your caloric requirements to get to the next day. When you're a hunter-gatherer, we've talked about hunter-gatherers in here, right? When we were doing the bean thing, right? Have we talked about
Yeah.
hunter-gatherers? Hunter-gatherers living hand-to-mouth. When hunter-gatherers are living hand-to-mouth, they're really attempting to just meet their caloric requirements for the next day. Now, that's gonna be, because you're a hunter-gatherer, that's gonna be a mixture of sugars and proteins and fats and other things. But when a hunter-gatherer comes across a colony of honeypot ants, you guys know what honeypot ants are? Look them up. Look up on your digital devices what a honeypot ant is. Honeypot ants, they occur in Australia and southern Africa. Australia and southern Africa are places where there are still some cultures that exist as hunter-gatherers. What do you notice about those honeypot ants?
Big ol'.
Gigantic abdomen full of sugar water, full of honey. And when a hunter-gatherer who's normally out there picking up insects and nuts and berries and stuff, when they get to a colony of honeypot ants, you know what they do? They sit down, they destroy that colony, and they just eat them until they're all gone. Because as a hunter-gatherer, where you're living on the edge and your goal is to make it from one day to the next by meeting your caloric requirements, when you come into a little treasure trove of sugary ants, you grab them by the head and thorax, you pop the abdomen into your mouth, pop the abdomen off, and you swallow it, and you get this jet of sugar, and you just sit there and eat those ants until you can't find anymore. We'll continue talking about the Golden Corral on Wednesday.
Again, I feel like
I think I told you to explain to me
Do you not think about that before you go to Golden Corral?
well, that's my thing. It's like I feel like there are like days where my cat's
do
just like, I'm
fish
not
and you
gonna
put
eat
your line in.
today. I'm like, like today's just not the day. Like,
These
how can you always be
little
thinking about
fish
eating?
are
Don't you
so
get tired
full of water,
sometimes?
and they're going.
What about fun? I feel like my animals are fun.
Yeah, I do.
But all you do is
All you do.
normal search.
Come through.
That's why they're attracted.
I do get tired.
Possibly, yeah, so they're picking up a vibrational cue, which sends them the message. I mean, that's the whole basis of fly fishing to a certain degree, is it's the fly hitting the surface of the water. But that's different than,
This is like with the weight, and you sink it, and it falls down, there's no vibration, it's purely just on the food that's in the area of the fish.
yeah, but that's only one prey item in a lake or a stream or something that has probably a lot of prey items. And so, that prey item would have to be big enough and
It's usually is big.
have to be big enough and attractive enough to a fish that would attract the fish's attention. So, yeah, I'm not sure what, because
I was just thinking about
you
fish
plunking it in
fish.
here, your success is gonna be dependent upon a lot of other things, because these fish may be getting plenty of food over here, in which case there's no incentive for them to go over there. This is why fishing is sometimes better at some times of the year than other times of the year. This is why people go ice fishing in the winter, is because during the winter you have generally less food, so when you drop your hook down through a hole in the ice, you're the only patch in town.
Yeah,
okay, maybe that's a better